Okay, here comes part 2 of the video. We've already done all of these problems. Alright, and now we're picking up with number 15. Alright, we're going to learn how to simplify all these exponential expressions and radical expressions. But first, one more time, remember, pencils down, people. Do not do your homework along with the video. First, do the assignment by yourself as best you can. Then check your answers using the answer key posted on Edmodo. Then watch the video, skipping to the problems you got wrong or could not complete. Still no copying. Redo the ones you got wrong by yourself. Alright, but enough with speeches and advice and thanks. Let's get started. Okay, we need to simplify no negative exponents. So here's what I would recommend. Let's deal with the parentheses and the exponent. We got to do that first. Exponents come before multiplication in the order of operations. So this ba to the fourth power, that's just going to come down. Ba to the fourth power. So we're just doing this over here. Now here's what I recommend. We need to do this negative 3 power to each one of these three things. So let me make this really clear to you. Okay, how do I want to do this? Alright, so we've got this 2, and we've got this b, and we've got this a to the fourth power. I want you to see them as three separate things. So now I've got this negative 3 power that has to happen. So I need you to understand that we are going to do the negative 3 power to all three of these things. Okay? So far, the main thing that's going to happen right here, this is going to be a to the negative 12 power, okay, because you multiply those. So basically this is what I have right now. I've got b, a to the fourth power, times 2 to the negative 3 power. I've got b to the negative 3 power and a to the negative 12th power. Okay? Now, anything with a negative exponent is going to move to the other side of the invisible fraction. Right now, everything is starting off in the numerator. But this 2 is going to drop down because it has a negative exponent. This b to the negative 3 power is going to drop down, and this a to the negative 12 power is also going to drop down. Okay, so that means what are the only things that will remain up? Okay, we've got the b, a to the fourth power, that's going to stay up. Okay, but down here I will have 2 to the third power. Once it drops, it becomes positive. And I will have b to the third power, and I will have a to the positive 12th power. Okay, typically when the power is 2 or 3, we go ahead and evaluate this. So 2 to the third power is 8. So typically we will go ahead and make this an 8. Okay, so that would be our answer to number 15. Alright, what about number 16? Let's apply those same skills. So again, I've got this 2. Now, hopefully you know that anything to the 0 power is 1. So I really don't need to write 2 times 1 because that's just 2. Okay, so I'm going to ignore that. So I've got this 2, I've got this y squared. And so this negative 3 power, again, is going to have to be applied to both of these things. Okay, so the 2 is going to get a negative 3 power, and the y squared is going to get a negative 3 power. Okay, this is not in the parentheses, so that's just going to come down the same. So far I have 2 to the negative 3 power, y to the negative 6 power. Alright, a power to a power, you multiply. and then times 2 y x to the third power. I'm just bringing that down. Now, anything with a negative exponent is going to drop to the denominator. Everything is starting out here in the numerator. But this is going to drop down, and this is going to drop down. Okay? So that is going to give me, okay, I'm going to bring this up over here. So the things that will remain up are the 2 and the y and the x to the third power. These two things drop down, so I'll have 2 to the third power and y to the sixth power. Okay, now I need to simplify anything I can. Now please, I'm going to show a step right now that I want you to do in your head if you can. So skip this step. But here's what I want you to be thinking. When I see 2yx to the third power, here's what I think. 2y, but x to the third power is x times x times x. Okay? When I see 2 to the third power, I think 2 times 2 times 2. And when I see y to the sixth power, I think y, 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 y. So, I keep this all in my mind, but anytime you see x to the third power, I want you to picture it as 3x's, and so on. Because that makes it much easier to see what's really happening. The 2 that's in the numerator is going to cancel out one of the 2's that's in the denominator. Okay? The y that's in the numerator is going to cancel out one of the y's that's in the denominator. And nothing's really happening with the x's. Okay? So as we get back to the problem, in the numerator, all I have is x to the third power. Okay, in the denominator, one of my 2's is gone. I just have 2 times 2, or 2 squared, but let's go ahead and put 4. Okay, and we used to have 6 y's, but now we only have 5. So that will be y to the fifth power. I guess I didn't need that giant fraction bar. Could make it smaller. Okay, so that will be our final answer. So again, even though you won't be showing this purple step, when you look at it, I want you to think, alright, this 2 is going to cancel out one of these 2's, so it'll be 2 squared. This y will cancel out one of these y's, so it'll be y to the fifth. That's your thought process. Okay, number 17. Now, if I were you, the first thing I would do is I would move anything that has a negative exponent. Okay, you saw that if something was in the numerator and it had a negative power, we moved it down to the denominator. Well, guess what? If I see something in the denominator that has a negative exponent, I'm going to move it up to the numerator. So this k to the negative 3 power is going to come up and become k to the positive 3 power. Okay, there I just moved it. So now everything's in the numerator, so this will be easy to simplify. So this will just be 2. Now I've got 3k's, 2k's, that's 5, 3 more, that's 8k's, so that's k to the 8th power. Okay, we're adding all those exponents up. Alright, number 18. Okay, well, first I have to deal with this, power raised to a power, before I do anything else. So that's going to be negative 12. Okay, so I'm just going to recopy that. So I have x to the negative 12th power, and then I have x to the 4th power, and I have 2x to the negative 3rd power. So all I did was multiply these together. Alright, now, there's a lot of different ways I could do this problem. But what I recommend to you is go ahead and move anything that has a negative power right at the beginning. Okay, so I am going to move this and this. Alright, the 2 is not attached to this. Okay, these two things I just circled have a negative exponent, so they are going to move to the other side of the fraction. Alright, the things that I did not circle are going to stay right where they are. So the 2 doesn't move. The x to the 4th power doesn't move. Okay, so just to make it really obvious, I'm going to change color. So this x to the negative 3 power is going to move up. Okay, and this x to the 12th power is going to move down. So I'm going to have x to the 3rd power, it goes up and becomes positive, and down here I'm going to have x to the 12th power. So now that everything's positive, it should be pretty easy to simplify. Alright, let's go ahead and simplify the numerator here. So this is going to be x to the 7th power so far, and that 2 is just sitting there, and I've got x to the 12th power. Now I'm not going to write this out like I did before, but remember, this is 7 x's, like x, 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 x 7 times, and this is 12 x's. So these 7 x's will cancel out 7 of these x's. Okay, so it's going to leave 5 x's, and obviously they will be in the bottom because that's where there is more. In the top, we're just going to have 1 to hold the place. And you know what? I said I wasn't going to show it, but I just can't help myself. Just real quick, let me show you what just happened. Because there's always that one kid that's like, wait a minute, what did you do and how did you know? And where's that 1 coming from? So this is for you, kid. X to the 7th power. 1, 2, 3, 4, 5, 6, 7. There's that 2. X to the 12th power. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And again, I do not want you writing this out under any circumstances, but it is helpful if you picture it happening in your mind. So these 7 x's in the top are going to cancel out 7 of these x's in the bottom. Okay, so look, that leaves 1, 2, 3, 4, 5 x's. That's why it's x to the 5th. So again, the real problem happens because kids just want to subtract, and they'll say 7 minus 12 is negative 5, but then sometimes they're not sure whether to put it on the top or the bottom. Okay, that negative 5 is sort of a hint to you that it's going to go on the bottom. Alright, also the 2 is there on the bottom. What about this 1? Well, remember, when we're canceling things out, what we really are doing is we have the same thing in the numerator and the denominator. Well, what's the value when you have the same thing in the top and the bottom? Well, it's just like if you had 5 over 5 or 3 over 3. That's a value of 1. So when we're doing all this canceling, we really are making 1s. So if everything cancels out, it's not surprising that we're going to have a 1 holding that place. Okay, that was a long explanation for something sort of simple. Okay, so that was number 18. So number 19. Okay, in order to add radicals, radical expressions, we need like terms. In other words, the only thing that's allowed to be different is the coefficient. Alright, these numbers are allowed to be different, but everything I'm about to highlight in yellow has to be the same. Okay, this and this and this. Those things I just highlighted in yellow have to be exactly the same in order to add them together. The coefficients tell us how many we have. So at a glance it might seem like we can't do anything because the radicand is different for each term. Radicand is like the 18 and the 12 and the 27. But then you realize these are not simplified. So what we need to do is simplify each one of these radicals. So let's do that right now. So for right now, the 3 in the front, we're just going to keep that. As I look at the 18, I'm trying to think of a perfect square factor inside of 18. 18 is 9 times 2. 9 being a perfect square. Okay? Always put your perfect square first. I'm going to put it in red so you can follow what's happening. Alright, then we have the 3. I'm just bringing that down. Now 12. What perfect square factor is inside of 12? Well, 12 is 4 times 3. 4 being a perfect square. Okay, and what about 27? Alright, I just brought down that 2. What perfect square factor does 27 have? 27 is 9, perfect square, times 3. Okay, the purpose of factoring each one of these numbers as a perfect square times something else is that the perfect square part can be reduced. I can take the square root of 9 and the square root of 4 and the square root of 9. Alright, when you take the square root of a number, it does not stay inside the radical anymore, does it? Actually, let me put it right here. So the square root of 9 is 3, and it won't be in a radical anymore. You understand what I'm saying. The square root of 9 is 3, not radical 3. So that's why it's going to be outside of the radical. Square root of 4 is 2, and that's going to come outside of the radical. And I just said it already. The square root of 9 is 3. So everything in red is going to simplify and come out. Everything in blue is going to stay right where it is. Alright, I can't take the square root of 2 or the square root of 3. So first I'm going to copy down all the blue stuff to be really obvious. So there's my 3 and there's my radical 2. Okay. Alright, there's my 3 and here's my radical 3. There's my 2 and there's my radical 3. I just copy down all the blue stuff as though I erased the red. But the red is not erased, it's simplifying and coming out. So the square root of 9 is 3. The square root of 4 is 2. And the square root of 9 again is 3. Now when there's already a number there and you're pulling out that square root, you are multiplying. This is multiplication between these two. So now I'm going to have 9 square roots of 2 plus 6 square roots of 3 plus 6 square roots of 3. Okay? Now, we can only combine the things that are the same. This number in front tells me how many I have. But this radical is what I have. So I have 9 of these, 6 of these, and 6 of these. Which of these are the same thing? Well, these are the same. Okay, radical 3 and radical 3. I have 6 radical 3's plus 6 radical 3's. Alright, I can't add radical 3's and radical 2's. It's like apples and oranges. Okay, 6 of these and 6 more of the same thing will make 12 of these. So if I put these together, I'm going to get 12 radical 3's, you could say. Okay, so the 9 radical 2's, I just bring that down. So that is as far as we can go. Okay, I feel like I should mention to you that your calculator can sometimes simplify these expressions for you. And sometimes you're allowed to use your calculator, sometimes you're not. So it's important that you know how to do what I just showed you. But let's see if the calculator will do this one. Alright, using your TI-30XS multiview, we can go 3 square roots of 18 plus 3 square roots of 12 plus 2 square roots of 27. Kabam! Alright, so the calculator's writing it in the other order, but it's the same thing. 12 square roots of 3 plus 9 square roots of 2. So we were lucky this time. We could have used our calculator at least to check our answer. The calculator will sometimes give you a crazy decimal like that, and that's not useful. Alright, anyway, this video is getting a little bit long, so I feel like I should accelerate. Okay, luckily on this one there's nothing to simplify, so we can go straight to like terms. See the radical 5 and the radical 5? Those are the terms that can be put together. Just understand that this is like one radical 5. So negative 3 and negative 1 make negative 4. Okay, so that'll be negative 4 square roots of 5, and then I'm just going to bring down my negative radical 6. Okay, that's as far as we can go with number 20. Alright, number 21. Now, when I was adding, I was very careful to make sure I had like terms. The radical part had to be exactly the same. Alright, same index, same number. Everything had to be the same except for the coefficient. But when you're multiplying, what's important is that the index is the same. As long as you have square root and square root, you can multiply. Or if you have cube root and cube root, you can multiply. The radicand, the 12 and the 6, do not have to be the same. So let's go ahead and multiply this together. So that's going to give us, well, 6 times 12 is 72. So this is going to give us 3 root 72. Alright, now you might ask yourself what perfect square goes evenly into 72. And if you're very clever, you're going to realize that 36 goes into 72. Alright, 72 is 36 times 2. Now, a lot of students aren't going to recognize that, so I'm going to show you what you could do if you didn't see that right away. But this is the quickest way, so I'm going to show it first. So, like I mentioned before, the square root of 36 is going to come outside the radical. So I will have 3 and my square root of 2, that part is just stuck. But the square root of 36 is 6. And then I've got 3 times 6 is 18. So my final answer is going to be 18 square roots of 2. Okay? Now, another thing that you could do, when you see the square root, you're asking yourself, what perfect square will divide into 72? And the first perfect squares you think of are 4, 9, 16, and 25. So the first thing you might try is 4. So if you do that, you might grab your calculator and go 72 divided by 4, and you realize that that is 18. So you might use that. So you might say, okay, this 72 is 4 times 18. Alright, now this is the long way, but sometimes this will happen to you. So as you keep going, then you're going to have your 3, and then your radical 18, and then the square root of 4 is 2. Okay, so far you have 6 radical 18. And that does not look the same, but the thing is, you're just not finished. If you look at the 18 now, this is a smaller number than 72. So now you can look at it and again ask yourself, are there any more perfect square factors in here? And now it's into your multiplication facts. So you can easily look at this and go, oh, 18 is 9 times 2. So now you're doing the 9. Okay, so that'll leave you 6 and then your radical 2, and the 9 comes out because the square root of 9 is 3. Okay, and then of course 6 times 3 is 18 radical 2. So that eventually gets you back to where we started from. Again, this is probably one of the types that the calculator will do for you if it happens to be a situation like the end of course test or the SAT or the PSAT. All of these situations you're allowed to use your TI-30 here. So there's no shame in using that calculator when you're allowed to use it. Alright, but on the quizzes and tests, be prepared to do it by hand. Alright, last problem. Okay, again, I'm going to multiply. So that -4 is just going to hang out for a little while because the radicals are going to multiply. Now 5 times 20 is 100. So this is going to be the square root of 100. But 100 is a perfect square. I should have made it in red, but I'm not going to. So this is going to be -4 times 10. Square root of 100 is 10. So that will just very quickly give us -40. And that is our final answer. Okay, I hope this video was helpful. I hope you did not copy off the video like I reminded you at the beginning, because you will not learn that way. I won't be there for you to copy off of when you're taking your quiz. So please make sure you can do every single problem on this assignment solo. Alright, I will see you on the next video, guys.